Thank you. Okay, so yesterday we were looking at some examples like this stuff right here. I think this is kind of where we left off. We'll finish this one up maybe. Right, we were looking at some examples where we're given 2 points and we wanted to come up with the equation of the line. Now let's think back, click all the way closely. Let's think back to what our strategy is here, right? We know that we've got this point slope form, which is really useful to us as a place to dump information about the line. And the name of the form is really telling us everything about it, isn't it? This is the form we use when we know the coordinates of a point and we know the slope of the line. And then we dump that information into point slope form and we're able to get the equation of a line really easily from there, right? Okay, so if we have 2 points, the problem became we weren't just given the slope. Like in these other examples we did, the first ones we did, they were pretty simple. They gave us a slope and a point, and all we had to do was substitute -4 for m, and then x1 and y1 are the coordinates of a point, so I would substitute -1, that goes for x1, and +7 goes in for y1, and I just plug and chug, right? Plug those things in and solve for y, and I get an answer. Okay. This one is one step harder because they're not giving us the slope directly, but we know how to find the slope, right? Is everybody real comfortable with this idea of what the slope is then? The slope formula. Okay, we went through that yesterday. Does that make sense? Okay, so this is how we define m. It's rise over run, and here's the picture that we drew yesterday, and I thought this was pretty good, right? If we've got 2 points, the point x1, y1, and the point x2, y2, to find the slope, we make a slope triangle, right? We're going to rise by that much and run by that much. Well, how much are we rising, right? We're rising from this y value to that y value. That's that distance right there, isn't it? Now, what if that were 10 and that were 4? How far did we rise? How'd you know that? You subtracted them. You did 10 minus 4 and you got 6, right? Well, the same thing if it's a y2 and a y1. If I want to know how far we rise, it's just going to be y2 minus y1. Tells us the rise, doesn't it? The difference in the y values. And the run is just the difference in the x values. It's just going to be x2 minus x1. Tells you how much did you change your x values, right? Okay, and then, so there's our rise, there's our run. And so that's our slope formula. y2 minus y1 over x2 minus x1. So for this one, we had to calculate the slope first. And so we could take I got to do y2, so -8 minus -5 is +5. That's going to give us a -3 on top. On the bottom, we get 1 minus 10 is -9. -3 over -9 is +1/3, so that's our slope. So that's what we're plugging in for m. And for the values of x and y, we'll just take our pick, whichever point we want to use. We used this one, the 10 and the -5. Doesn't matter. But we got to pick one point and use only that point. You can't mix and match them, right? So our x value was 10, our y value was -5. When we plug that stuff in, y minus -5 is y plus 5. Here I get a 1/3 times x minus 10. And so all we got to do now, the last steps are what? Distribute the slope and add like terms, right? Okay, so let's talk about this part because it's a fraction. And I think we always need a little practice with fractions, right? So if we distribute the 1/3, everybody agree we're going to get y plus 5 equals, well, you tell me, what am I going to get?
1/3 x minus
1/3 x? And what's 10 times 1/3? When I multiply fractions, how do I multiply them? No, it's easier than that. Multiplying fractions is the easiest thing you can do. Straight across, right? Straight across. So I'm multiplying 1/3 times 10/1. What am I going to get? 10/3. Yeah, so I get minus 10/3, right? Last thing to do is what?
Add 5, or minus 5.
Subtract 5. Okay, so there's the part we want to focus on, right? So let's focus on that last part there. We're going to subtract 5, and then we get y by itself. on this side, we get our 1/3 x, but what about this stuff? We've got a minus 10/3 minus 5/1. Okay, so let's slow down here and let's think about this. I know you've done this a million times in your past, but you don't do it very often. Mr. Haywood tells me you could use the yellow calculators to do this in Algebra 1, is that right? So you didn't get a lot of practice with it. So we gotta get some practice. Yes, sir?
Would it be negative 25 over 3?
It is, but now I'm not worried about the answer so much yet. I wanna know how we get there.
You would just turn 5 over 1 to 15 over 3.
Okay, so now we've gotta get, what do we call that though? What do we have to do? In order to add or subtract fractions, we need a what? Common denominator, right? And our common denominator of 3 and 1 is gonna be 3, right? The smallest number that 3 and 1 divide into is 3. So we gotta get a 3 on the bottom, which means we need to have thirds on the bottom here. Well, how do I do that? I gotta multiply the bottom by 3, but what does that also mean then? Gotta multiply the top by 3. Now, that shouldn't be such a big mystery. Let's think about why we did that. If I'm multiplying the top and the bottom by 3, isn't it the same thing as multiplying by 3 over 3? What's 3 over 3 equal to? 1. What's special about 1? If we multiply by 1, that's our multiplicative identity, right? That's the number we multiply by to keep the identity the same, right? So it makes sense. We're not changing this number. The value is staying the same. We're just changing it to look like a different fraction is all, right? And so if we do that, we end up with multiplying straight across, I get negative 15/3. And now I just have to combine those two terms, right? Negative 10/3 minus 15/3 is what? Negative 25/3. And the important thing is you keep the denominator the same, right? That make sense?
I have a question.
Yes.
So, the whole, keep coming back to it because it blows my mind every time, but the whole math discovered thing or whatever, who sat there and like figured out fractions, right? Like that whole thing, right, where you have to multiply by 3 on both the top and the bottom. I mean, if I didn't know math, I wouldn't have figured that out.
No, you're right. And it's, but this is one, you can reason through this, and let me think of a way to explain this better. So what if here's a way to think about it, like if 10/3 is just 3 1/3, right? So think about, I know this sounds juvenile, but this is really good. Think about this in terms of like pizzas, right? So I would, in order to really, to cut a pizza in this way, it'd have to be cutting it into thirds. Agreed? Does that make sense? That would be 10/3 of a pizza would be, I get 2 pizzas, whole pizzas cut into thirds, but those are, and then we got 1 extra piece, right? Or 3 whole ones and then 1 extra piece. Well, 5/1, that's just a whole pizza not cut into anything, right? If I want to be able to add this up conveniently and come up with how much pizza is there combined when I combine these numbers, I know this sounds dumb, but all it means is I gotta cut the pizzas the same way, so that I'm talking about the same size slices is one way to think about it, right?
Makes a lot more sense.
And so I'd have to cut this into thirds. So now if I cut this one into thirds, I've got 15/3 means I've got 5 complete pizzas cut into thirds. But now when I mix all these pieces together, I've got the same size pieces. Does that make sense? Okay. So that's really more of just a matter of an issue of convenience, Okay, so our final answer then, it's a good question already. So y equals 1/3 x, and then all this is going to combine into negative 25/3. And there it is. Right, there's our answer. Okay, very good. All right, so we got 4, 6, 10, 13, 16. Oh man, we can about do 1 per board. Let's do that. Perfect. So we can use the front boards if you need to. Does everybody go to a board where you do a little board work real quick? This is going to count as your e-ticket for the day. Really, what I want you to see here, and let's get everybody, I know put everything else away. I want to get total focus here. If you can just kind of go hard in the paint for about 10 minutes on this, we're good to go. I think if you can engage with this a little bit, you're going to see this, and this is very helpful. This is kind of one of those little more subtle details. This is a little higher level stuff. So, Joe, why don't you close that up? I got to get you up here. Everybody got to be up here. So linear equations, right? Now, whenever you're using linear equations and kind of word problem stuff, applications, there's two different kinds of problems, and I want you to see both of these, and there's really only two kinds. That's it. They're different though, and if you can see what the difference is, it makes this so much easier to deal with these, right? So here's one of them. Let's read through this one and we'll come back to it. A cab ride costs $4 plus $1.75 per mile driven. Then we're gonna use that to build a model and answer some questions. Question? Comment?
The
Oh,
A, I just wanna know if I got it right.
Oh, yeah, we'll get there, we'll get there, we'll do this one in a second. So now, what about this one here? This is another one. Josh bought 3 bags of potting soil and 10 bags of mulch from Home Depot. Write an equation to represent the total cost. Do you see anything different about those two? One of them is just screaming slope intercept form at you, this first one. Why is this one, can you immediately tell, okay, this is gonna be a slope intercept one? There's something there, they give us something that must be a slope. What about the $1.75?
Per mile.
Per mile, that's it, right? When you get something like $1.75 per mile, what do we call that in Algebra 1? When you have like a cost per something, or you get like miles per gallon, or it's,
Like Mr. Griggs, I don't know.
what, say it again?
Like Mr. Griggs, I don't know.
Remember calling that a rate?
Sure.
So a rate is something, like a rate is something that's accruing, you know, it's always a per something, right? Like in this case, it's $1.75 per mile driven. In order to calculate the total cost, we're gonna have to multiply that rate by what? $1.75 per mile, we'd have to multiply by what? Say it again? The miles, yeah, right? Whatever's on the bottom of that rate, we gotta multiply by that to see what it all adds up to, right? So when you see something like that, when you can see a rate in a rate is always equal to a slope every time, right? A rate equals a slope, and so that's telling you right there that this is gonna be in slope intercept form because they're giving you a slope, right? What's the other part of that then? This $4. Remember back in the day, back in Algebra 1, when you guys did problems like this in slope intercept form, we said that M was the rate. What was B?
$4.
It's the $4 in this case. What do we call it in general?
Constant.
Like the constant, you could call it the constant, we could call it a lot of times you probably called it the start value. Do you remember that?
Oh, yeah.
The start value or the fixed cost.
Fixed.
So it's gonna be the part that doesn't change, right? It's constant, it stays the same. What about this is the start value or the fixed cost? Well, the $4, right? The cab ride, you're gonna pay $4 no matter what. The $4 is just a flat fee, okay? But then you've got this rate of $1.75 per mile. Okay, so let's put this in terms of an equation then. So it says, write an equation to represent the cab fare. Define your variables. Okay, so what do we want cab fare, what are we gonna call that? You pick a variable.
Y.
Say, what's it gonna be?
Y.
We call it y. So if we say y equals cab fare, that's fine. And then what's the other variable here? That's the output variable, isn't it? Because we're representing, we're always representing the output, right? That's what the function is meant to calculate. That's what it represents. So what's the input gonna be there?
X miles.
X, okay, miles, good. Distance or something like that, right? So x equals miles.
Somebody actually raised their hand for once.
Okay, so then we've got, here's our slope intercept form, y equals mx plus b. Now, did we have to call y, the cab fare y? No, we could have called it like c or f or something too, right? Doesn't matter, we can always replace these variables, but the point is that we're gonna have the output variable here and the input variable is multiplied by the rate, right? So in this case, we're just gonna get y equals, what's our rate in this problem? What's our rate, Garrett? What's our rate in this problem? Say it again. 1.75. 1.75 times the distance in miles, so 1.75x plus, what's our fixed cost? What's our fixed cost, Gabe? 4. There it is, right? That's our model. Okay, that's giving us cab fare is the output and the input is number of miles. Okay, so for part B, if Clay's destination is 17 miles away and what's it say, he has $30, will he make it? How do we find out? Plug it in, yeah. Plug in 17 for X and see what the output is. If it's more than 30, he doesn't have enough, right? So if we do that, if we plug in 17, what do we get? 1.75 times 17 plus 4, that's gonna be 33.
29.75.
33.75, is that what we get? So 33.75, so does he have enough?
No.
Nope, doesn't have enough.
You'll have to walk.
He's gonna have to walk, I agree. Okay, so now what about this one? This is different, right? This one doesn't give us a rate, right? It doesn't give us, it gives us two of the same thing. Now, in a slope-intercept kind, it's giving us like a fixed cost and a rate, right? They're different. One's an M and one's a B, and they're different. This is one that's gonna fit not slope-intercept form. Which form is it gonna fit? Standard form. Standard form. Yeah, this is, yeah, yes, it says it right there, doesn't it? This is the one that's gonna fit standard form, so it's gonna look something like AX plus BY equals C. Where in this case, X and Y are gonna be the input variables, right? And we're calculating something like some kind of overall cost, okay? So in this case, it's telling us he's buying 3 bags of potting soil and 10 bags of mulch from Home Depot. Write an equation to represent the total cost. So the total cost, we gotta define our variables. Let's just let C equal total cost. What are the other inputs gonna be? So we're trying to calculate total cost. What are the other things we've gotta know before we can calculate total cost? If he's buying 3 bags of potting soil, what else do I need?
The cost of the potting soil.
Cost of the potting soil, right? So we'll call that, how about P? P is cost of a bag of potting soil. Okay, what's the other thing we need?
How much for the bag of mulch?
Bag of mulch. He's buying 10 bags of mulch, but if I want the total cost, I gotta know the cost of a bag of mulch things. He's buying 10 of them, right? So M, I don't wanna use M, that'd be bad. We're gonna use,
B.
Well, I guess we can use M in this one. It's not slope intercept, that's fine. So M equals cost of a bag. Cost of a bag of mulch, right? So there's our variables. Now we gotta come up with a model for this. So so overall cost, in this case, happens to be a C, is gonna equal something times one input plus something times another input. So in this case,
BP plus 10M.
let me move this down just a little bit. Okay, so what about the potting soil? He's buying 3 bags of potting soil, and each bag of potting soil costs P. So what's the total cost of all the potting soil?
Come on. It's 13 something.
But I don't want the answer. I
Oh.
wanna know how to write that. What am I gonna put here? I think I heard it.
3P
Each
plus
bag of
10M.
potting soil is P, and he's buying 3 of them.
Oh, shoot, hold on. I got you.
3P. Everybody see that? Okay, what's that mean? So let's think what these things mean. C is the total cost, right? Everybody agree? So what's 3P? So Dominic, you tell me, interpret that. There's more to come. I'm not done. We're gonna add another term to it, but let's focus on this one. If we got 3 bags of potting soil and each bag costs P dollars, what is 3 times P? That's it, the amount of dollars for potting soil, right? So that's gonna be cost of all potting soil. We could call it maybe, right? There's the cost of all the potting soil. What's the last part of this equation gotta be? 10M, and what's that gonna be? Hey, Lonnie, what's that gonna be? Cost of the mulch, right? Because we got 10 bags and each bag costs M dollars. So all that stuff is the total cost of the mulch, right? That make sense?
That makes sense to me.
Okay? And then, so we're not gonna finish this problem today. If Josh spent $40.91, what is that? Is that gonna be a C or a P or an M?
C.
That's a C. Okay, so we're plugging in 40.91's going in for C. And mulch costs $2.75 per bag, that's what? That's M. The only thing left to solve for is P, right? So we can find it. Okay, we'll wrap that up first thing tomorrow, and then you guys can work. Whew, that's a lot of teaching.